the meeting. Okay, it's taking
Okay,
a while.
I have it open on here, so I'll tell you if the stream goes live. Oh, the stream is live.
Oh, as in we're on stream.
Yep, we are on stream.
Lovely. Wait, I don't see. Oh, okay, we're on stream. Cool. Hi everyone, welcome to Battlecode lecture something, I'm not sure. We're doing intro to Git today and my name is Serena.
And my name is Andy, and we will be teaching a lecture on how to use Git.
Yeah, so first thing that we're going to do is download Git and also make a GitHub account. So just do this during the lecture because there will be a live coding section near the end where you can follow along later. So here are the links to download Git, and this one is for making a GitHub account. And Andy, can you put those in the chat? So what is Git? Git is basically a version control system. And what this means is that it allows you to track changes in your code projects and basically keep track of different versions of your project. So as you can see here, we have this original file, and then we make a change to it, and this change will be recorded by our version control system, which for us is Git. And here's the new file, and as you can see, you can keep making changes, and those changes will continue to be stored. Another thing Git allows you to do is have multiple collaborators work on the same file. So for example, one person could make this change up here and another person could make this change down here, and then you can merge those changes, which we'll talk about later. So let's talk a bit about why we want to use Git. Mostly, I would say it's for the collaboration it allows, because multiple people can work on the same set of files, and Git will allow you to merge them together basically automatically, well, most of the time automatically. And Git also allows you to separate new features to your code onto different branches. And this allows it so that when you're working on a new feature, it doesn't like pollute your current code base. And it allows you to basically keep a version of your code that's clean, separate from the version of your code that you're working on. And a good thing about Git is that it will save every single version of your code that has ever existed, that you have ever committed to Git. And this allows you to go back and look at what you worked on before, and you can even revert back to those changes if you want to. Okay, so the way Git works is it basically has 4 different sections. Your working directory, which is a local copy of your code that you'll make changes to, you'll add bug fixes to, etc. And then the second part of Git is the staging area. And this is where you put your changes that you want to record. So after you make your changes in the working directory, you'll stage the changes that you want to commit to a record, and those will go in the staging area. And then after you stage them, you can commit them, and that will record them to your local repository, which is basically Git's way of keeping track of like everything that's ever happened to your code. And if you want to push these changes to a remote repository, for example, if you're working with multiple people and you all want to store your code changes in this remote repository, you can use git push and push all those new commits to your remote repository. So some common commands that you'll use in Git is git add, which will move your changes to the staging area, git commit, which will move your stage changes to actually being recorded in your repository, and git push, which will push your new commits from your local repository to the remote repository. And then the opposite of push is pull. So let's say your collaborator pushes some commits to the remote repository. You don't have these commits. So to get them, you will call git pull, and that will copy the changes over to your local repository. And then we have git status and git clone. Git status basically tells you the state of your working directory and your staging directory. So it'll tell you which files you've changed since your last commit, and it'll tell you which of your files are in your staging directory. And then git clone just allows you to copy, basically download a remote repository to your computer, and that will be your local repository. Okay, now onto Git branching and merging. So branches basically allow you to work on new features without corrupting working code. You can put things like bug fixes into new branches. You can put whole new features onto new branches. Basically anything that you want to separate out from your main code base. And the way you create a branch is just saying git branch and the name of your branch, which here is new feature. And then to switch to your branch, you say git checkout new feature. And we'll show all these commands in our Git demo later, which Andy will be running. So let's say that you have two branches and you want to merge the changes from one branch to another branch. Say you have a bug fix branch and you want to merge those changes into your main branch. What you'll do is on your main branch, you'll say git merge and then the branch name that you want to merge in. And that will basically copy the changes from that branch over to your branch. And Git does this like all automatically, so you don't have to worry about anything. Sometimes, however, things go wrong and merge conflicts occur. So this happens when two people change the same bit of code and Git doesn't know how to merge them. So the way you fix this is Git will give you this kind of angle brackets and more angle brackets and an equal sign line. And it'll tell you the changes that you've made on this branch and the changes that the other branch has. And you basically do this by hand. You combine the two. And in this case, we've combined them to be ASDF FDSA. And then you just commit the changes and that's your merge. Here's a link to a Git cheat sheet because I know it's very hard to memorize all these random Git commands. And honestly, I don't have them memorized either. But yeah, this link will be very helpful. Okay. Yeah, Andy, could you send the link in chat? And then to configure Git, let's just, if you've downloaded Git for the first time, you need to configure it with your username and your email. So type these commands into your terminal, replacing first and last with your actual name, of course, and your email with the email that you made your GitHub account with. And this will allow you to follow along with what Andy is going to do. Oh, that's the last slide.
All right, so now we'll just be moving into a demo on how to actually use Git and hopefully move away from things like Google Docs, which are functional, but not desirable. All right, so we'll start off just with a quick intro. So Git itself doesn't rely on, so GitHub is a very useful website. It's essentially just a way to sort of share code with others and sort of a way to utilize Git in a bit of a user-friendly interface. You might have noticed that the Battlecode 22 scaffold, or the basic bot that we give on our website, is in GitHub. And this makes it really easy to sort of take and use. So we'll be giving a demonstration on how you can initialize a new Git repository, how you can clone this repository and use this template to sort of use this bot as your initial base, as well as how to sort of push and collaborate with others on Git. So hoping everybody can see my screen. This is my IntelliJ. If you weren't there for lecture 2 days ago, we helped set up IntelliJ. You don't necessarily need to use IntelliJ. I'm just using it. It is a pretty easy way to view the code. And there's also a very nice terminal down here that I can do all the Git commands with. So we're gonna be going over a few things. So the first thing is we're going to show you how to initialize an entirely new Git repository that has nothing in it. So this is actually a very simple command. If you've already downloaded Git and set it up, all you have to do is you type git init, and then you give the repository the name that you want. So let's say here I'm just making a clean repository and I want to name it AndyBot. So I create this repository here, and you see now there's a new folder called AndyBot here. If I enter it, there is currently nothing in it, but let's say I don't know, I make a file called like andybot.java or something. You can see this file exists, and we can sort of see the different things that we can do with Git on this repository that we'll be covering later. So the simplest way to create a completely fresh repository is just git init. Now, sometimes we don't want to create a completely clean repository. For example, what probably most of you will be doing is using this Battlecode 22 scaffold as sort of the base of your repository and as sort of the template you're using. So we sort of navigate to this very conspicuous and obvious button. We click use this template here, and we can give it a repository name here. So here I'll call it something AndyBot2 just for simple naming. You can make it public. This just means that anybody can see the code. Not everybody can change the code, but everybody can see it. Here you see there's an option for private. I believe on GitHub, in order to make private repositories, you actually have to pay a bit of money, but public repositories are fine. So we'll create this AndyBot2 template, and you see it'll take a few seconds to generate the repository here. And we have a completely new repository that is the exact same as the Battlecode 22 scaffold that we have here. So we look at this is an exact match where every file is the same. And we've essentially just copied the repository to something that we can work with and change without changing like this main scaffold. Now, of course, now that we've created a new repository, we actually need to get it onto our computer so that we can actually change the code in a sort of a manageable format, that we can import the project and all that fun stuff. So the easiest way to do that is to just click on this code button in green here. It'll drop a little, it'll sort of make a little drop down here with this very convenient link. If you just click it, it should automatically let you copy it. And you see it says this is how you can clone a repository. So cloning a repository is essentially taking one of these repositories from online, for example, and just porting it to your local system. So it's very easy to do. You just need to find a place you want to clone the repository into. You need to make sure that you're not currently in a Git repository. So for example, if I cd'd into AndyBot, it's not going to let me clone the repository, or it might cause some errors that we really don't want to run into. So we're just going to make sure that we're in a clean area. We're going to clone this repository here. We see that it successfully cloned it. And now we have AndyBot2 on our local system. And you see, as everything that was in the example funcs player, we can go to the example funcs player. If I can type example funcs player code here, and we can sort of look at it if you really want. And you can see all the very nice example funcs player code here. Okay, so that's the two easiest ways to create a repository. Here, instead of using the example funcs player, I'm going to be working on the lecture player, which is sort of the bot that we've been working on over the past 2 lectures, so we can sort of build onto it and maybe make some improvements that can get carried on to future lectures here. So here's the example funcs player code that up here. I already have the file open. If you want to open it, you can sort of reference lecture 2, where you set up the project. Just click open and open up the project by navigating your directory. And here, I've decided that maybe the best goal for today is to make some modifications to the example funcs player so that we can implement some kind of laboratory system. So currently the example funcs player doesn't actually use laboratories. You can see if you go to the robot player, in the case that the robot's a laboratory, you just panic. You don't do anything since it currently doesn't try to build any. So today we're going to be trying to add some functionality for laboratories while demonstrating the various features of Git. So the first thing that we need to do then is to go to our builder strategy file. Some of you will not have this. It should be in the robot player file if you're following along from the standard example funcs player. And we can see that builders are currently never building lavatories. So if you look at this line, this is the line that orders the builder to create a watchtower, but they never actually create lavatories. So let's try to change that. We can just copy this line so that we can use it as a basic template. And we can say, well, let's say the lead amount is greater than 10,000 and the turn is a modulo of 150. Then let's try to create a lavatory. So we can just really quickly tweak these lines and then turn this into an else if. And all of a sudden, our builders are hopefully going to be building lavatories. So that's the first change that we're going to quickly implement just to allow for some additional functionality. Now that we actually have lavatories as a possible unit, we need to actually tell them what to do. So here you can see we have the respective methods. If it's an archon, we want to access the archon strategy file and call the run archon function. Similarly, we're just going to do something very similar here. We're going to access the lavatory strategy file and call a function called run lavatory. If it's hard for you to follow along what's going on with the code, there's no worries. The focus on this demo isn't really improving the code at all. It's really just demonstrating various features of Git, and we've just chosen to sort of, make the lavatories better as a method to do this. So we're going to pretend like there's a lavatory strategy file, which we're actually now going to create. We're just going to call the run lavatory function from that file. So now we just need to make this file. Sort of tie up the loose ends here. IntelliJ actually very kindly asks us if we want to add this change that we've made to Git. In the case that we're running with IntelliJ, we can just click add and it'll make sure to update the Git and stage this change for us. Just so that it's a bit simpler for everybody else, we're just going to click no, because a lot of the time, I know a lot of you guys aren't using IntelliJ. Maybe you're using Eclipse, maybe you're just running from terminal, and it won't give you this option. So to code our actual lavatory, all we really need to do is to create a function called run lavatory, and it should take in a robot controller as a parameter. And it should also throw a game action exception. And here we're going to want to import everything from Battlecode common as the builder strategy, the archon strategy, and all of the other files do. And very simply, we're just trying to create a very simple model of what laboratories might want to do. Well, what might they want to do? If you have enough lead, let's try to convert some of it into gold. So if rc.get lead amount of your team is greater than, I don't know, let's say you have more than 10,000 lead, 5,000 lead, and you're able to transmute, let's just try to transmute. Very simple alchemist function. All it does is look at the amount of lead. If you have a lot of lead and you can transmute, try to do so. Otherwise, do nothing. And looks like we have, okay, no error in this file, just needed to click on it to update. And now let's get into the actual Git content here. So if you notice, we've changed a total of 3 files along the way here. We've changed the builder strategy file. We changed the laboratory strategy file. In fact, we created a laboratory strategy file, and we changed the robot player file. So a very handy command as, oh, whoops, hold on. Here we need to just go to our actual Git directory. Here. So this is our Git repository that I've been working on. It's just the lecture player one. And if we run the git status command, a very handy command that Serena demonstrated earlier, it'll tell us all of the changes that we made. So you can see we haven't staged any of these 3 changes, meaning that they're only on our working directory, only we have them. And you can see it mentions the builderstrategy.java file, the robotplayer.java file, and the laboratory strategy.java file. So we're going to want to git add all of these. One way you can do it is just by typing in the name of each of these files, which does certainly get a little tedious. You have to type it 3 times and the file lanes are pretty long. You can see here, once we've staged one of the files, it'll mention it and it'll say you've added the changes here. Alternatively, you can just say git add dot, and this will add all of your changes to staged. So now you can see we've gotten ready to stage all 3 of these files, and now we just need to commit them. So git commit is sort of the command you use to actually commit your changes to the local repository you have. If you think back on the graphic we had, you have your working directory, you have your staging area, you have your local repository, then you have the remote repository. So here we're just going to push, or we're going to commit all of our staged changes to the local repository, where they're actually sort of they mirror the the remote repository. So one really useful command here is just the -m. When you commit, you need to sort of say what you're committing. So here we're going to say laboratory improvements. And the -m indicates that this text right here after the commit is our message. So here you can see that we have found that we've that we've committed all of these laboratory improvements. And now we just need to push them to the main repository. And now if you sort of go back here, this is the lecture player. If we reload this page, you can see my change has showed up on the official lecture player Git repository. We navigate to sort of these files where I was making the changes. You see we've updated these 3 files. We can even click in and sort of look at what these changes are. You see that now we have a run laboratory function and a laboratory strategy.java file. Now, there's a few other commands that are super useful here. Once again, if we run git status, we see that there's no longer any changes that we've made that haven't been committed and pushed since we've pushed our changes. And the other really useful command here is the git log command. This is just going to show you a log of all of the changes that have occurred on the Git. So you can see the most recent one is from me. It's laboratory improvements. Before that, we have one from Aiden from yesterday's lecture where he's running fixes and lecture 3 changes. And even before that, if you just scroll down, you can see Jerry's initial commit from lecture 2 on Tuesday. All right. So now we're going to go over some other things. So let's say we try to run like a Git. Let's say we want to see if anything has changed from another person. So we can sort of look at Git status. Let's say like, let's say somebody else has made a change, right? And we're sort of trying to move, we're sort of trying to figure out what changes they've made, and we're trying to pull it into our own system. So the command you use for this is git pull. Essentially, it looks at the remote repository, the one that everybody shares, and it grabs all of the changes other people have made, and we can just git pull them. And we see here, there's actually been one change that's been made. So if we look at our log now and see, wow, Serena has made a change to our Git repository while I was talking. The lead requirement for laboratory is actually updated. So originally when I typed in the lead requirement, I said you need 5,000 lead. If we update this file, suddenly it's 7,000 lead. So Serena's decided 7,000 lead is a better threshold for whether or not we want to convert. She's pushed that change through the same methods we used. And now we can pull this change to get it onto our own repository so that we can have a shared copy of the code at all times. That's just how you use the git pull command. And we can once again sort of look through the log, and you see here she's pushed her most recent commit of updating the lead. And before that, I was just making some laboratory improvements. So let's say now that I've sort of implemented the laboratories, I've decided, I've actually looked a bit more into the strategy, and I've decided, right now, if we go to our Archon strategy file, we have this really nice set of if conditions, where it sort of looks through some different logic and it decides, what kind of things should we build and where should we build it. Well, let's say I've done some more research and I say, wow, I found this magic ratio of miners and soldiers that just completely steamroll the example func spot. And I really want to implement this now. So I'm going to very excitedly go here to the miners and ratios line, the miner and soldiers ratio line here. I'm going to say, wow, instead of building miners when there's less than half of the number of soldiers, let's try to do it when there's, 4/3 the number of soldiers. And this magic ratio of miners to soldiers is going to let us completely destroy the example funcs robot and just win Battlecode. And the other change we need to make is, well, let's say we don't want that many builders and we just want a bunch of soldiers. We're just going to try rushing the opponent. Well, let's try changing this to, 30. Let's say we only build one builder every 30 soldiers we have. And these two magic ratios are just going to let us win the game. So we're really excited about this, and we're going to run a status just to check. We see the change has been registered. We need to add this change. Once again, we can use the dot if we just want to avoid all this typing. And then we're going to try to commit this change. We're going to say magic ratio lets us win the game. Wow, okay, our commit worked. So now we're going to try to push this change. We want everybody, all the people that we're working with, to admire how great this change is and see how great it is. We're going to push. Oh no, what happened here? It looks as if our push was rejected. So what happened here is that Serena at the same time made a similar change on the same lines of code. So recall that Git is used so that we can edit code files from multiple people very easily. But what happens when two people try to change the same line? Well, do we go with Alice's suggestion? Do we go with Bob's suggestion? Do we throw away both of them? What Git will do here is called a merge. So if Serena wants to change this line and I want to change it as well, it's going to be like, well, whoever pushed it last needs to figure out what's supposed to happen here and then fix the merge conflict. So you can see the push failed because we essentially, it says that the remote contains work that we do not have locally. In other words, we tried to work on some lines that the remote already had work on. So in order to figure this out, we're going to have to resolve the merge conflict. So what we're going to have to do first is a git pull so that we can pull the changes in the remote repository over here, and we can sort of decide what to do. And we see that the automatic merge failed. In other words, it wasn't able to just like take Serena's changes, take my changes and sort of interweave them together. It actually means that we change the same line and thus we get a conflict. So if we click here again, it looks really ugly. But essentially what's going on here is this is the head. So this is what I have. This is the line that I tried to change it to. And this is the line that she tried to change it to. So I tried to change it to a ratio of 4/3. She tried to change it to a ratio of 6/11, and we don't know whose magic ratio is better. So being the natural negotiators that we are, we're going to do the best thing that could happen here and just take the average. Actually, the average is a little too much. Let's just take the ratio, 9/10. And we're just going to decide that, this ratio is somewhere in the middle of 6/11 and 4/3. We're just going to sort of go in the middle and, hope one of us had the magic strategy that's going to let us win. So you can see this is the commit number that she had. If we run a git log, we can actually see this number mirrored. Actually, sorry, we can't see this number mirrored yet because it doesn't have her push here yet. But this is her commit number. This is mine. And we're just going to take this and resolve the conflict by sort of just, taking the middle ratio. And now that we've resolved this conflict, we can look at the status again. We can add our changes, and then we can just commit and be like, fine, we compromise. I spelled that wrong. Compromise with our ratio, sad face. And then if we push this, the push works. So this is a very simple example on how merge conflicts can occur, sort of how you can handle them, and the different ways you can pull and push from repositories. Now, besides that, there's also another topic we want to cover, which is branching. So Serena, earlier in the presentation, Serena mentioned a branch. Essentially, a Git branch is sort of a copy of the code that has been changed in some ways, but you don't really want to put it with the official version yet. So for example, here's the lecture player. If we look at this, you see my most recent commit with my sad face on compromising ratios. But let's say we really want to make a volatile change, something that might be a good idea and might not be a good idea, but we don't want everybody to get this change because it's not really something that we've thought of fully through. Maybe like it causes our robots to just completely explode. And we don't want to really push this change to the main branch where everybody has the code, but we sort of want to push it to GitHub so that we can save it and collaborate with others on it still. So what a branch is essentially a branch of the code where it sort of splinters off from the main branch. And it says, well, there's some changes on this branch, there's some changes on main, and they're currently sort of just separate copies of the repository, which could get merged in the future, but that's something that's up to the people to decide. So we're going to try to create a branch, make some changes on it, and see how that goes. First command that's sort of useful here is the git branch command. This will essentially list all the branches that exist. Right now, there's only the main branch. We haven't made any new branches. So this is sort of what we'd expect to see. Let's say, once again, that we want to make some really volatile changes to our laboratory that might be a really good idea or might be a really bad idea, but we don't want to keep it. We don't want to we don't want to push to the main branch because we don't know if it's really a good idea at all. So we're going to create a new branch. And the way you do this is using the git branch command. And we can call this branch something like, I don't know, laboratory test. And here we can type in main as the second to show that it's a branch off of the main branch. So laboratory test will start off as a copy of main. And then when we make new changes, when we push to laboratory test, it's not going to affect the main at all. Once again, if we list all the branches, we can see now laboratory tests exist as a branch. Now to swap to laboratory test, there's a very handy command. You just type git switch and you type in the name of, if I can spell, laboratory test. And if we type in git switch laboratory test, it should swap us to the branch. And you can see this is what's happening. Oh, whoops. You can see this is what's happening because now it's highlighted in green. One other thing I forgot to mention earlier, Eclipse and IntelliJ, being the lovely IDEs that they are, actually offer a lot of functionality for Git that is super useful and super visually appealing. So this is the Git log feature of IntelliJ. You can see all of the commits have been done. You can see here where we had our merge conflict and I had to sort of carry it off, fix the conflicts, and then it can merge back to the original. And you can see all the very nice commit comments and sort of what's been going on with this repository. There's also a commit section here. This is if you just want to pick what changes you want to put in. For example, if I decide to add a comment, oh no, I don't know. Oh no, I can click this change and I can commit it. I'm not actually going to commit this just because that is just a demonstration of what you could do. But this is a very handy feature of IntelliJ. And I believe there should be an equivalent feature on Eclipse that you can find online. All right, so let's actually try to work with our branches now. So we're currently on the laboratory test branch, and let's look at what thing we want to do. So I don't know, our volatile change for today is going to be if the amount of lead is over 50, we're just going to try to convert it to gold. We've decided the best strategy, just turn all of our lead to gold and just transmute as much as possible and just constantly transmute. And in order to do this, we're going to decrease the threshold to 50. And I don't know, we can go to builders and just tell them to build tons of lavatories. Every 30 turns, we're going to check if we can build a lavatory. We're going to build one if we have more than 5,000 gold, 5,000 lead. And we can make another strategy change in like the Archon strategy where we just build tons of builders. We just want builders all over the place that they can build more lavatories for us, produce more gold, and we're going to be the richest people and probably not have a lot of soldiers or miners at all. So with these three changes, we can first check whether or not these three changes have been registered. They have. We see the three changed files under Git status. And we've decided some of these changes might be a good idea, some of these might not. So we don't want to really push all of them onto the branch yet. We're only going to push the really stable ones, such as the change to the Archon strategy. We only want this one to go through. The changes to the builder strategy, changes to a lavatory strategy. Oh, hold on. Here, I just forgot to type the git add. Remember to actually type your commands when you're typing these things. And we've staged the Archon strategy change where we're changing the amount of builders we have, but we really haven't added the builder and the lavatory strategy changes. These things are things that we just want to test on a local machine, make sure that it works properly before we shove it onto the main branch, shove it on to the laboratory testing branch. So with this, we're just going to commit the changes to only one of the files. We're going to say changing Archon strategy to have more builders. We're going to commit this, and we want everybody to see this change, so we're going to push it. And here we run into an error. The error here is that when you create a new branch, in order to actually push to it the very first time, you actually need to type out this entire very handy command they give you here, which is basically a way of making the main repository register this branch, recognize its existence. So right now, if we go here, this branch doesn't exist. We're going to push to it with this very special command. We see it succeeds. And now if I reload this page, wow, we have a new branch. And very handily on GitHub, we can navigate to this new branch. We can click around on it. We can be like, what changes happened? It tells you the most recent changes and the most recent commits. We see the changes Archon strategy, and we see, wow, there's a change. We can see that the ratio of builders to soldiers is different. Now, with this very handy tool under our belt, we suddenly realize, wow, that was a terrible idea. We don't actually want the Archon strategy to be different. That was the really unstable change. The laboratory test, the laboratory changes and the builder changes were the really good ones I wanted to put in. Well, how can we do this? Well, the first way to do it is to just, change this number back and push the new changes to the branch and everything's good. But what if I forgot what this original number was? Or what if I changed maybe like 50 lines of code and I'm really not into just like, retyping these 50 lines of code into what they originally were? Well, to do this, I would need to know what the original code was. So we're going to look at our Git log, and we can see our most recent one here, changing Archon strategy to have more builders. And we're going to say we want to see what the code base was like before this commit right here. We want to see what it was like at this commit. Well, once again, Git has a very handy function feature called Git checkout. So here's our commit number. This is sort of the ID of the commit, and it's sort of, with this commit ID, you can sort of identify what commit people are talking about, what the code was at the time. And we're going to run the function Git checkout, and we're going to give it this Git commit ID. And what this essentially allows us to do is it allows us to view the code base at this time. So if we run this function, hold on. Yes, if we run this function, we're now going over the code base at the time of commit 7BE bunch of garbage, garbled numbers afterwards. And we see this thing has changed back. It's no longer soldiers divided by 5. It's soldiers divided by 30, which is what the original was. And we say, wow, now I remember the number, and I can just, take this number, go back to the original by doing a git switch to the lavatory. That is going to be the last time I misspell lavatory. We're going to swap back to the laboratory test branch with our new knowledge of what the number originally was. You can see it updates back to 5 because this is what it is, what the most recent number is on the branch. I'm going to say go back to 30, and we're just going to make this change. Now we can check our git status again, and we see we need to add the change of Archon strategy. We can add this change, we can commit it, and we can be like, change was bad. Sorry, everyone. And we push this so everybody knows that we're sorry. And now that when we go back on our branch, we can see laboratory test. Whoops, wrong branch. Laboratory test now is what it originally was. It's divided by 30. Now let's say you make a ton of changes, like, I don't know, you change like 50 files and you completely destroyed the repository by accident, and you don't really know what to do since everybody's GitHub now shows like empty pages and garbled text, and you don't want to just check out and copy and paste back into 50 files, and that's really inefficient. There are a lot of methods to just revert the commit and reset the commit. In fact, those are the 2 commands you can use, I believe. If you go and search this up, git revert and git reset, this allows you to do so. But we're not going to really cover that since the commands tend to be pretty lengthy and pretty hard to remember. And also you can end up messing up the repository if you're not too careful. So you can search these up individually if that does happen to you. And usually copy and pasting Git commands from Stack Overflow turns out to be okay. So with that in mind, this is sort of how you can use branches. There's a few other ways that you can, manipulate branches around. So first, let's just add the rest of the changes we had. We can just commit them and be like, other changes for volatile laboratory gameplay. Okay, I lied when I said that was going to be my last misspelling. I don't know, you can put like a nice emoji afterwards. We push this, and now we have our very new volatile gameplay that only affects laboratory tests. We go back to main slash change was 13 minutes ago. And that was just the change I commit earlier. So this is the easiest way to use Git branches. Now, let's say you actually want to put laboratory test and main back together. You want to reintegrate a few features. The way you do this is going to be through pull requests. And we won't be covering that today because it is a bit more complex. But it's usually not, it's usually pretty simple. Just speak with your other teammates before putting in random pull requests from your volatile branches. And yeah, this is just sort of the very basic features of Git, how you can use them to share code, to make changes, to revert changes, and to merge changes together from different people working on the code. That's all we're going to be covering today on the Git demo. If any of you guys have any questions, I recommend you post it in chat and Serena and I can answer it. And if there are also any other questions on Discord, we can also answer those under the lecture channel. Let me see if there are any questions in chat right now. Yes, you can use Git checkout to switch between branches, as Serena stated. And yeah, lots of commands that you can use in Git. If you really want to search all of them up, you can probably find a big checklist sitting around somewhere. And yeah, that's all we'll be covering today for GitHub and Git.